Okay, so we say like for our division, like let's say like this is 16 divided by 3. So we have like a quotient is 5. Let's say, and okay. So we say this is the remainder. So sometimes we need to find the remainder. Like when this number is divided by that number, what is the remainder? So when remainder is 0, like if this division remainder is 0, then we can say this number is a factor of that number, right? So this question, is this number a factor of another number? This almost equivalent to say whether the remainder is 0, right? Okay, so now let's check some problem. Like we want to find the remainder when this number is divided by some other number. So let's check this problem. Like so here check divided by those small number, like 2, 3, 4, 5. Those small number. Okay, so let's say so. We say we have this big number. So this divided by, suppose this number n. Okay, so this number divided by 2. So remained. So we use this notation. Divided by 2. So we say remainder is 1. Right? So we just check the last. This number is odd number, not even. So how about divided by 3? So divided by 3 is we have this law divided by 3. So we just check the addition of those digits. Let's say we just check, oh, this number 1 plus 2 plus 3 plus 4 plus 9. We just check this plus 9 plus 6 plus 7 plus 8 plus 9. We just need to check this number divided by 3. So what is the remainder? So we say, oh, this is 3, this is 3, this is 3, this is 3, and this 3 also divided by 3. So remainder is 0. Okay, so how about 4? So we check 4 is 100 divided by 4. Remainder is 0, right? So we just check. So we for those number like 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just check. Oh, this part is this number multiply 100. So we just check 89. We just check 89, right? So 89 divided by 4. So we say remainder is divided by 4. Remainder is 1. So 88, right? Plus 1, right? Okay. So divided by 5. So 5 we just check last, because 10 can divide by 5, right? 10 divided by 5 equal to. So we just check the last digit, 8. So 8 divided by 5. No, last digit is 9. So divided by 5. Remainder just like 9 divided by 5. So remainder is 4. Okay. So how about 6? So for 6, yeah, so we have a little bit of trouble for 6. So For this problem, we can check we can divide by 6 directly. Like, okay, like 1 to 12, this can divide by 6, yeah. And this 34, so 30 can divide by 6. So, right, this is divided by 6. So then we just check 4, 5 divided by 6. We say 2 can divide by 6, right? 2 can divide by 6. So here become 36. 36 can divide by 6. So this one divided by 6, or this is like 18, or this is divided by 6. Yeah. And then 9 divided by 6, so remainder is 3. So how about 8? So 8, so for 8, we do not have enough space here. For 8, we just know like 1000 divided by 8 is 125. Okay, so for this number, so we just cut here. So we just this part is this number multiply this multiply 1000. This can be divided by 8. So we just need to check like check 7, 8, 9 divided by 8. Just find the remainder. Okay. So this is really easy, right? Okay. Okay. So divided by 8, and remainder is 5. So divide by 9. So let's see, how about 9? So for 9, we just check it just like numbers like divided by 3. We just check the addition for those digits. This number can divide by 9. Okay, so we say what is this number? We can add them up. Let's say 1 plus 2 plus 3 plus 4, 5, 6, 7, 8, 9. Okay, so this is 10, 10, 10, 10. So 40, 45. Okay, so 45, this is added them up is 45. So 45 can divide by 9 is okay, right? So divided by 9, remainder is 0. Okay. Okay. So here just we just repeat like divide by 2 easy. Divide by 3 we use this way. We just check the addition of the digits. Divide by 4 because 100 so easy. Divide by 5 easy. Divide by 6 a little bit tough. Divide by 8 easy. Divide by 9 easy, right? Find the remainder easy. Okay, so now let's consider the problem. This number, so this big number. Yeah. So when this divided by 3, what is the limit? So for this number, we can change this as we just divide by 3. So we just try to find a number close to 3. So at the first we say this equal 450. So 4 can be written as 3 plus 1. Okay, so 3, so this we just check last digits like this. Okay, so we say remainder is 1. Okay, so here the same story. Okay, so this number divided by 3, what is the remainder? So we can check like, okay, so here we can say this equal, we just change this as 4. So 450, 200, yeah, 5, 300. And this is 4, we can write this as 3 plus 1, 250. And 5, we can put this 5 as 3 plus 2, 300. Okay, so this we can forget the 3, just 1, 1 is 250, just 1. And this one, forget the 3, just 2, 300. So this is 2, 300, we can change this as 4, 150. And we write the 4 as 3 plus 1. Okay, forget the 3, so this just equal 1. 150, right? 150 is 1. So remainder is 1. Okay, so how about the divider is big, a big divider. So we want to find the remainder of this number divided by that number. So when divided is big, like let's say when this number divided by those like 12, 15, 45, so this is those numbers quite big. So how can we solve such a problem? So we we can use this way. We just say like we just factor this 12. We can write 12 as 3 multiply 4, and 15 is like 3 multiply 5, and 45 just 4 times 9. Or 5 times 9. Okay. So divided by 12, remainder. So we just check the remainder divided by 3, the remainder divided by 4. So we say n divided by 3, remainder is 0, right? So we already find it. N divided by 4, remainder is, let's say we already check this, remainder is 1. Yeah, so it's 1. Okay, so from here we can say n equals 3k. 3 multiplied some number. Also, n equal 4 times some number. Suppose 4n plus 1. Okay, so this n should satisfy those two conditions. N equals 3k or n equals 4n plus 1. Okay, so we want to find n divided by 12. So the key idea is 4 in this n. We just check. We just put n equal 3. 3. Let's say we use the name 3m plus r. So this R, we can say like any number can be written as 3 m plus some remainder. So this remainder can be 0 or 1 or 2, right? So we just plugging this in by this. So we say n equal 4 3m plus r plus 1. So this equal 12m plus 4r plus 1. So for this n, we know divided by 4 remainder is 0. Yeah, divided by 4, this is divided by 4 remainder is divided by 4 remainder is 1. So this part divided by 4 remainder 0. This divided by 4 remainder 0, right? And also, so we use this condition: n divided by 3 remainder is 0. So we just check divided by 3. Divided by 3, so remainder this part is 0. So how about this part? So we say 4r plus 1. This number divided by 3, remainder is 0. So we just check which r, like r, you have the 3r, 3 possible r, which r satisfies us. So we just put like this, let's say, so r equals 0 is okay. We say not okay, right? This is not okay. Then r equal 1 is okay. 1, if r equal 1 is 4 times 1 plus 1. 4 times 1 is 5. 5 divided by 3, remainder not 0. So this is not okay. So then how about r equal 2? We find 4r is 8. 8 plus 1 is 9. 9 divided by 3, remainder is 0. So this is okay. So we know this r should be 2. Okay, so we can find n equal 12m plus 9. Okay, so this number divided by 12, remainder is 9. So for big divider, maybe we can use this way. So for divided by 15, I use this way. Like we divide by 15, we want to find. We know divided by 3, what is the remainder? Divided by 5, what is the remainder, right? Divided by 45, same way. Okay. Okay, so go back to here. We say for this number divided by those numbers, 2 is easy, 3 is easy, 4 easy, right? 5 easy, 8 easy, 9 easy. Only 6 we have a little bit of trouble. Okay, so maybe we also can use this way, like 6 equal 2 times 3. So we can find the remainder divided by 3 divided by 6. So we can check it, the remainder divided by 2, the remainder divided by 3. Then we can get to the remainder divided by 6. Okay. So for those big divider, use this method. So actually, these things are related to a theorem called Chinese remainder theorem. So the Chinese remainder theorem is just ask those questions. We have some number n. We know this number divided by a1, remainder is r1. This number divided by a2, remainder r2. Like that. So we want to find when n What is the limit when n is divided by this big number, like a1 times a2 times a3, like that? So the idea, so the theorem, we don't need to remember, but we just use this idea, right? If this number divided by a1 limited at r1, we can write this n1 as a1 times k plus r1, right? So this is basic idea. Okay, so now let's check this problem. So here we have some number. So it's not this number divided by 3 remains 0. Divided by 4 remains 1. So what is this number remained? What is remained divided by 12? So we can use this like divided by 3 remains 0. So n equals 3k. So divided by 4 remaining is 1. So n can be thus. So we can change this k. We can write this k in terms of 4n, or we can write this n in terms of 3, like 3l plus r, right? Yeah. So this is key point. Then we just find we have some possible r value, like here divided by 4. Remainder could be 0, 1, 2, 3. So we just find which one satisfies these two conditions. Okay. So other way is if this number is not so big, so we can find some typical number. We can find typical n. Let's say we can do this. Okay, n divided by 3 remaining 0, so this n can be thus, right? 3, 4, 6, 9, 12, 15, 18, 21, 24, like that. So from them, we just try find one that satisfies this. If they are divided by 4, remains 1. So which one? So we check divided by 4, which one remained is 1. So find this 21, right? 21 satisfy both of these conditions. Okay, so then we just say 21 divided by 12 remainder is 9. Okay, so now let's consider this problem. We have a very big number. N equals this. 1, 2, 3, 4, 5. So we just write those numbers from 1 to 43, 44, 45. Just from 1 to 45. So we have this big number. We want to find the remainder when n is divided by 45. So this 45 is, so the idea 45 is big. So idea is we just factored 45 as let's say 5 times 9, right? Also you can say 49 can be 5 times 3 times 3, right? So here we don't need it. So we can check this number divided by 5, divided by 3, divided by 3. But here we prefer this. We don't need to use this. We just check it. This divided by 5, divided by 9. Then we can find the remainder divided by 45, right? Okay. So at first we say a divided by 5 remainder is 0, right? Because the last digit is 5. And this is divided by 9. Okay, so we need to find this limit. So divided by 9, so we need to add those numbers up. Let's say, so 1 plus 2 plus 3 plus 9, then plus, we can put a 10 here, 10. Okay, then 11 plus 12 plus 13 plus 19 plus 20, so plus 21, so then 31, then 41, 31, 30, and here, and here 40, then 41 plus 42, 43, 44, 45. So we need to add those numbers up. Okay. So we can do many ways. We can find this, like, okay, from here, find this, add them up. What is this number? 55. And what is this number? So from here to here, just plus 1, 10, 10, 10, 10, plus 100. Then plus 100. So we can use this way. But we also have a good better way, like let's say 1 plus 2 plus 44 plus 45. Okay, so we find this plus this and this plus this same, like 1 plus 45, 46. And another 46, right? So we can say how many 46? So here we just check, like here 1, 2. So how many? So we just say just half of them. So here let's check this. Let's say 1. We just a small number 1. Let's say, how about this? 1, 2, 3, 4, 5. Suppose we have 5 number. Saying this 1, this, and this, and 6. So we have like how many 6? How many? We can say like not this plus this, not 46 with half. Okay, 23. So how many 23? We say we just have 23. We just have, let's say, almost we can, actually, like we can use this the middle one. So here 1 plus 2 plus 3 plus 4 plus 5, we just say equal 5 times 3. Like we just say 3, 3, 3 looks like 3, 3. So this is 2, this is 2, 3, this is 2, 3. Yeah, use this way. Yeah. Okay. So middle one is 23. So 23, how many 23? 45 23. Okay. Okay, so this number is equal to this, 23, 45. So 45 divided by 9 is 0. So we say in divided by 9 remains 0. Okay, so divided by 49, so we say n equal 5, okay, and n equal 9, okay. Then we can say n equal just 45 multiple some number, or we can say we just change this n as 5l plus r. So r equals 0, 1, 2, like that. So we can find, so what is r? We can find r equals 0. So we say n equal just 45 times some integer. Okay. Okay. So like this number, like if n divided by, we said n divided by 5 is equal to 0, n divided by 9 is equal to 0. Saying actually we can get this conclusion: n divided by 45 is 0. Okay. So for such a problem, so we can change a little bit. Maybe we can delete 45. So how about this number? Or delete this. How about this big number divided by 45? So here maybe the remainder divided by 5, not 0. Like here divided by 5 remainder 3, right? So divided by 9 and not 0. So but we still, you can use the same idea to solve such a problem.